Hi, welcome to Algebra 2 Common Core. Tonight we're going to take a look at population parameters and how they apply to the statistics that we're going to look at in this chapter. First of all, we want to look at the difference between a population and a sample. So a population is a complete set of all subjects that share a common characteristic that is being studied. So a population can be all the members of a high school, for example, or all the members of a community. So it can range from a small population to a much bigger population. A sample is going to be a subset of the population. So it's used when the entire population is too extensive to study all. So for example, if we're at a very large university, we might not want to poll or to survey all of the members of the university, all of the students there. Instead, we'll take a smaller subset of that population. Before we get to measures of dispersion, I want to remind you of a term that you've heard before in statistics, measures of central tendency. I didn't put this part in the notes because this should be review for you. I just want to remind you of what these measurements mean. Measures of central tendency means measurements that we can use to measure how close together the data is to the center. So the mean, the median, and the mode are all measures of central tendency. In this lesson, we're going to take a look at measures of dispersion. If you look at that word dispersion, it means how much things are spread out. So one measure of dispersion is going to be the range. We know that to find the range, we are just going to take the maximum score and we're going to subtract the minimum score. So it's basically telling us the spread of the data. So if we were talking about our latest test results, we could say that the test scores ranged from a 72 to 100, so the range for that would be a 28. It tells how spread out the data is, 28 points apart from the minimum to the maximum. The interquartile range, sometimes abbreviated IQR for interquartile range, is going to be quartile 3 minus quartile 1. You should have been exposed to quartiles back in 9th grade in algebra. Quartiles are when we divide the data into 4 groups, where each group represents 25% of the data. So Q1 represents the 25th percentile, Q3 represents the 75th percentile. So the interquartile range is how far apart the Q1 and the Q3 are from each other. In a few minutes, we'll take a look at doing the quartiles by using our graphing calculator. Variance, that's going to be the average of the squared distances from the mean. Again, you should have been exposed to this term back in algebra. So we can find the mean of the data and then take a look at every score and find how far away from the mean each score is. Then all we have to do is square those distances, and that's called the variance when we take the average of those squared distances. We're going to be looking a little bit more closely in the next few lessons on standard deviation. Standard deviation is going to be the square root of that variance. So again, we're going to be calculating these using our calculator. Back in algebra, you did calculate those by hand, but in this class, we're going to be using our calculator. Now, a sample standard deviation is when we are using a sample, or again, a subset of the population. So this is going to be the standard deviation that we calculate using that subset. If instead we're finding the population standard deviation, that's going to be the standard deviation calculated for the whole population. And again, we're going to see these two quantities when we do our calculations on our calculator. So if you don't already have your calculator with you, please pause the video and go get your calculator because you will need it to do the rest of the examples here. So in example number 1, it said 18 students in Mr. Weiler's advanced calculus class took a quiz with the following results in ascending order. So you'll notice that these numbers, some of them repeat. So when they repeat, I put them into my graphing calculator under Stat, Edit. So again, I went to the calculator and I pressed the Stat key and I chose number 1, Edit. That allowed me to go into the lists in my calculator. So in list 1 I've got all the scores, but for any that appeared more than once in the list, I gave it a frequency in list 2 of more than 1. So any that appeared only once, I put a frequency of 1. So for example, 72 appeared twice on my list, as did 84 and 88. Also 100 later on in the list. You'll notice that what you see on the screen right now is not the entire list, because on your calculator you've got to keep going and fill in the rest of the numbers, 95, 99, and 100. So make sure you don't just replicate what's in this table on my notes, but make sure that you put all the rest of the numbers that I've listed down here as well. So we want to recall how to use our calculator to find the mean, the median, and the quartiles for this data set. So once we have the numbers in the list, we are then going to press the Stat key, and you'll notice that we arrow over 1 till we get to the Calculate menu. Within the Calculate menu, we want to choose choice number 1, One Variable Stats. Please do this with me as I go through it on the video so that you're aware of how to do this on your calculator. Now, when I've chosen One Variable Stats, this is the screen that should show up on your calculator as long as you've got the newer version of the calculator. You'll notice that the list is going to be the numbers that we have in list 1, so I've put L1. If your calculator doesn't already say L1, you're going to use the second key and then the number 1 key so that you get the L1 after the word list. For frequency list, if I've got more than one number, or if I've got a number that appears more than once, then I've put that in list 2. So I want as my frequency list L2. I'm going to use second number 2 to get that L2. Once I've got those set, I'm going to press Calculate, and I'm going to take a look at the screen that shows up. You'll notice that the screen has an arrow at the bottom, which means that I've got more information. So I've put it in 2 separate screenshots here so that we could see the whole thing and be able to label them all. So let's take a look at the information that my calculator gave me. The very first thing in my list is going to be that X bar. Since I've got X bar, I know that that stands for the mean. So I'm going to put that information up under A because it says let's find the mean. So the mean, also abbreviated X bar, in this case is going to be equal to 83.72 repeating. Now the next thing that's going to be important for us to look at is going to be the median. So the median on my list here, I'm going to have to arrow down. So again, I see that there's this arrow at the bottom of the list that tells me there's more stuff. So when I scroll down, I see that this number right here is the median. So the median for this data is 84.5. So make sure that you fill that in up here as well. Then I want to label the quartiles. So you'll notice that I'm given Q1. So Q1 is right here, 75. So let's list that down as well. And I also need Q3, quartile 3. That one is 93. So Q3 equals 93. Now the last information that I'm going to need for the box and whisker plot is going to be our minimum and maximum value. So looking carefully, I see that the minimum value is 56 and the maximum value is equal to 100. So all of the numbers that I need to make my box and whisker plot are right here. It's actually the last 5 things on the list once I do one variable stats. Now I'm going to pause the video for a minute. What I'd like you to do in that spot is to make a number line. We want to make the number line go all the way from 56 up to 100 so that I can fit the data. And then I'm going to come back and make my box and whisker plot. So again, this should be a reminder from Algebra 1. So I have created my number line, and my number line has the minimum and maximum value that I need for my data. So let's start by putting the information that I have about my quartiles and my median on my number line. So first of all, quartile 1 is at 75, so that's going to be about here, so I make a vertical line right there. Quartile 3 is 93, so I've got that right about here. And the median is at 84.5, so that's going to be right about there. So I create the box using quartile 1, the median, and quartile 3. To finish off the whiskers, I'm going to go to my minimum point of 56 and go from 56 over to the box. Then I'm going to go to my maximum value of 100 and go from my box up to 100. So you should see on here the minimum value over here, the maximum value over here. This is going to be my Q1. This is my median, which of course corresponds to Q2, and this would be quartile number 3. Question B says, what's the interquartile range of this data? So we defined it above. The IQR, or interquartile range, is always going to be equal to Q3 minus Q1. So in this particular case, the interquartile range would be equal to quartile 3, which is 93, minus quartile 1, which is 75. So that is going to tell me 18. Now if I look at my data, especially written on the box and whisker plot, I know that each quartile should represent 25% of the data. So 25% of the data is on this whisker, 25% of the data should be between Q1 and the median, 25% between the median and Q3, and 25% from Q3 up to the maximum. So if the question says what percent of the data should be between the first and third quartile, we're going to say that 50% of the data should be in that range. The question then says, is this true for this data set? So if I look at my data and I say, going from Q1 to Q3, I want to look at all the numbers from 75 to 93. In this set, there are actually 10 of my numbers, and again, make sure that the ones that appear more than once get counted more than once. So 10 out of the 18 numbers are in this range, so that means 56% are actually within the range. In general, we're going to say about 50% of the data, but for this one, it's 56%. Now when we take a look at our calculator output, there's 2 more measurements that I want to look at there, and those are my standard deviations. So I'm going to put a box around those 2 different standard deviations. The one that's marked S with an X, that's called the sample standard deviation. The one that is a lowercase sigma, it looks like a little scrolly O with the X, that one is called the population standard deviation. In general, in Algebra 2, when not specified, we are going to be using the population standard deviation. So this question says, what percent of the scores were within 1 standard deviation of the mean? So I'm going to actually split my work here because the part B is going to be, how about 2 standard deviations? So if I want 1 standard deviation, I'm going to say for this data, the standard deviation was 11.7. So I want to take my mean and I want to add on 1 standard deviation. So that's going to be 83.7 plus 11.7, and that's giving me a total of 95.4. I want to go the other direction as well. Go from the mean and subtract one standard deviation. So that's going to be 83.7 minus 11.7, which is giving me an answer of 72. Now it says we want to figure out how many scores are within that range. So if you look carefully at your list, the only ones that are not within that range are 56, 68, 99, 100, and 100. So 5 of them are not within that range. Therefore, 13 out of 18 are within that range. If I calculate the percentage, it turns out to be 72%. And there's actually no connection between this percentage and what that score was right there. It just happens to be that they're the same. Now let's do the same thing, but this time go from the mean and add on 2 standard deviations. So you can use your calculator to say take 83.7 and add on 2 times 11.7, and that gives me 107.1. Then take my mean and subtract 2 standard deviations. So when I do that, I'm getting 83.7 minus 2 times 11.7, and that's going to be 60.3. Now if I look at all of my numbers, I say that actually there's only one number that doesn't fit in that range, and that number is the score 56. So 17 out of 18 of the scores fell within those 2 numbers, and that happens to be 94% of the data. We're going to be talking about percentages of data quite a bit more in the next 2 lessons. In this lesson, we'd like to finish up by talking about the center, shape, and spread of data when I do a frequency histogram of that data. Now you can see that I've given you some examples of pictures that are these bar graphs or frequency histograms. Frequency histograms just tell how many of each score is occurring. And again, back in Algebra 1, you made a whole bunch of these frequency histograms. Now we're just going to be talking about them and using them to analyze data. So first of all, when I talk about shape, the shape can either be symmetric or it can be skewed. Symmetric means that the left and the right side are roughly mirror images of each other. So that's when my center is usually right in the middle of the data and the left side and the right side look pretty symmetrical. Skewed means if it has a noticeably longer tail on one side than the other. If I have a long tail on the right side, then it's going to be called skewed to the right. So it actually makes it pretty easy. I'm just looking for where that tail is. So skewed to the right would be that first graph right here, because I see that I've got this extra tail on the right side. Anytime I have a long tail on the left side, that's going to be called skewed to the left, and that's our second example right here, where I see that there's a longer tail on the left side. Besides shape, we'd also like to take a look at the center of our graph. The center is basically asking the question, where is the center? Where is the median / mean? And it's going to change depending on what kind of data I have. So median or mean is going to be important to us. The spread means how spread out is the data. Basically, what's my range? So let's take a look at a few other diagrams that show symmetric or skewed data. So you can see that the first one on the left side is a symmetric distribution. It's symmetric because the middle is right in the center of my graph, and the left side and the right side are symmetric to each other. You'll notice that when I have a symmetric distribution, that generally is going to mean that the mean and the median are pretty close to each other, right in the middle of my data. For the next graph, I see that I have skewed right. It's skewed right because I have a slightly longer tail on the right side. Now what happens with a right skewed distribution is that my median or my middle score is actually smaller than the mean score. And in the last diagram, I've got a data distribution that is skewed left, and that's because I have a tail on the left side. When that happens, the mean is actually to the left of the median. So the median being my middle score is over here, but the mean of the data is over here because the mean is affected by these lower scores that are over here on the tail. So when we look at a distribution, we're going to want to describe the center, shape, and spread for the data. So I'm going to do 1 or 2 examples and then have you do the rest as examples for yourself. Looking at example number 2, I guess I'm looking at example number 2, but it's number 1 within that. So I want to describe the center, shape, and spread for this one. So first of all, the easiest thing to describe is the shape. And for the shape, I definitely see that I have a tail on the left side. That's right here. So if I've got a tail on the left side, I'm going to say that this one is skewed left. Now, when I'm looking for the center, I want to take a look at the data and say where is approximately half the data above and half the data below. And if I look carefully, the center is going to be somewhere around here between the 10 and the 11. So I'm going to say it's approximately 11. And the last thing I want to talk about is the spread. For the spread, let's take a look at what the range is, or what the width of this graph is. This one goes from 1 to 13, so that tells me that my range is equal to 12. Looking at the second example, I see that I've got a graph that has its center right in the middle. So I'm going to call this center equal to, if you look at the numbers carefully, I know it's kind of small in the note packet, but I'm going to say the center is approximately at 120. The shape, this one is one that is nice and symmetrical. So I'm going to call this one that is symmetric. And lastly, again, I know it's really hard to see those tiny numbers, but the spread on this one goes from about 10 to 240. So I could say that the range on that would be 230. So do me a favor and take a couple minutes and describe the center, shape, and spread for examples 3 and 4, and then come back and compare with my answers. Hi, why don't you compare your answers with the ones that I've written? Again, I know it's kind of hard to see what those tiny little numbers are along the x-axis. You'll notice that the first example, number 3 really, is skewed right, while number 4 is skewed left. The centers, the first one was 180 to 185, the other one was 135. You'll notice though that the spread, while the graphs look pretty similar, we've got to pay attention to what the spread is as far as the numbers. So the spread goes from 160 to 230 on the first graph, while it goes from 40 to 160 on the second graph. So thanks for working on statistics tonight, especially our parameters, population parameters. We'll be doing some more work with this in class. Make sure if you have any questions about doing this, especially on your graphing calculator, please come see me during activity period so that we can get those questions straightened out before you come to class. We want to make sure that everybody can do these calculations on their calculator. Also, be sure to have your calculator in class with you so that we can practice some more. Thanks, have a great night, and we'll see you next time. Bye-bye.